All right, here we are on 6.5. We're almost halfway through this unit. Whew, look at us go. And today we're going to be talking about triangle congruence and similarity. So last year we focused on triangle congruence and similarity on just recognizing whether two triangles were congruent or similar. There were several properties that proved similarity and several properties that proved congruence. So let's go over those properties now. So if I have something that is a property of similarity that is side, side, side similarity, this is meaning there's a proportion between the side lengths, or in other words, there's a scale factor. So if I have a small baby triangle and a big triangle, side, side, side would mean I'd be able to make a fraction between all of its sides that were corresponding. So I would say that xy over ab would be the same thing as doing xz over AC, which would be the same thing as doing CB over ZY. Okay, that is what side, side, side similarity means. If it's side angle side similarity, that means we're able to say that two of those sides would be like this fraction, but you also have the angle in between them as congruent. So for side angle side, we would be able to say something like xy over AB is going to be the same thing as xz over AC. And you would also be able to say that angle A is congruent to angle X. Angle-angle similarity is really, really simple. It basically just means you just have to prove that two angles are congruent. So for example, you could say that angle A is congruent to angle X and angle B is congruent to angle Y. Okay? So similarity, you just need to prove that they have like the same general shape, but they can be different sizes. When you're saying something is congruent, you're saying they're exactly the same. So when I say side, side, side congruence, that means that all three sides are shown as equal. So either by showing it like this, or telling you the side lengths, or by having a shared side. There's lots of different ways you can find that information. Side angle side would mean that you have two triangles where you have two sides that are either marked as congruent or you can figure out are congruent, and the angle that is in between them, kind of like the hinge of a door, is also congruent. It fixes that last side has to be that one. If we do angle side angle or angle angle side, these are both building off of angle angle similarity. So angle side angle means that you have one angle, the side, and the other angle. So that angle, that side, and that angle marked as congruent. Angle angle side means you have this angle, and you have this angle over here, and then you have the side outside of the two angles. Something like that, marked as congruent in that way, or you can derive that information from the picture. So we're going to be proving some things. So the first thing I always do is look at my given. That's the first thing. So I've got FG is parallel to JK. So I know that these are parallel, and in fact on my picture they are marked as parallel. See those little marks? That is a marking of parallel. Now I'm just trying to prove similar. So for similar, I've got side, side, side similarity. I have side, angle, side similarity. Or I have angle, angle similarity. Oh, I forgot to write given. Look at me go. We're doing great today. All right, so we've got those are parallel, and that's given. So now I've got to figure out one of these. Now, because there is nothing written about side lengths, I highly doubt it's going to be anything to do with sides. So most likely, I just need to prove that two angles are congruent. Well, the first angle my brain sees is probably this vertical angle here. I know that JH, so the J angle JHK is going to be congruent to angle FHG because of the vertical angle theorem. Or vertical angles are congruent, whichever is fine. Okay, so I know that one, but I need one more. Well, because these lines are parallel, let me extend them out because this is a little hard to see when they have those endpoints. If I extend those out and I extend out this line as the transversal, all of a sudden I see all these angles that I couldn't see before. And I notice that this angle and this angle are alternate interior angles. So I know that angle F and angle K are going to be congruent because alternate interior angle. Now, is this the theorem or the converse? I want you to think about that to yourself for a second. This is the theorem because we're proving angles are congruent. We're not proving lines are parallel. So this is going to be the alternate interior angle theorem, not the converse. Okay, so we have an angle, we have another angle, and so we have enough to say they are similar. Well, I like to just take this statement right off of here. So I like to say that triangle FGH is similar to triangle KJH by angle similarity. So when we're talking about similarity, you do in fact actually need this little squiggle symbol to indicate the difference. Okay, we're going to do one more proof together. This proof is going to prove congruence, and then you guys are going to do 3 or 4 proofs on your own. So in this proof, we're given that AB is congruent to CD. So I know that this is congruent to this, and that's given. And I know that M is the midpoint. So we're probably going to be using the definition of midpoint here in a second, of DA and BC. Those are both given information. I'll just put them in the same column so I don't have to write given twice. Okay, so if M is the midpoint of DA, that means it's in the middle, which means that DM has to be the same length as MA if M is in the middle. So I can say that DM is congruent to MA by the definition of a midpoint. Okay? And because M is also the midpoint of CB, I know that CM has to be the same length as CB. So CM is going to be congruent to CB. And again, that's just by the definition of midpoint. So I'm just going to put those in the same section. So now if I look, I have a side, and a side. I have 3 sides. So I can say that triangle, and I'm just going to steal this from right here. We're going to say triangle DCM is congruent to triangle ABM by side, side, side. Now you can either write side, 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 or you can write side, side, side congruence. But when you're talking about congruent triangles, generally you don't need that congruent symbol. All right, looking here, you guys are going to now prove that these 2 triangles are similar. Notice that there's nothing about sides, so that should give you a hint for what you're going for. Here you're proving that these 2 triangles are congruent. Now they need a side that has something in it, but make sure to look at the given. It might give you some more information. Here you're going to prove that these 2 triangles are congruent, and when you are done with that, we will meet back here about proving the midpoint. So we're going to be proving something called the mid-segment theorem, and this is what builds that. So that is a perfect lead up into that, and we will meet back here in a few minutes.